We are going to do an example using in the FAA method. Well, we speak of only one runway of 10,000 feet in visual meteorological conditions with a mix of airplanes that we should determine going to the norm to see each one of the airplanes in which category fits. In the exercise this has been already done, as we have that A is 35%, BA 30, CA 30, DA 5%. We also have that 50% are departures and the 50% are arrivals, that there are no touch and goes, and that we have exit taxiways in the runway at 3,100, 3,900, 4,700, 5,500 and 6,250 feet. The first thing that we have to calculate is what is called the mix, that is C plus 3D, that is 30% plus 3 multiplied by 5, 15, that is 45. Why? Because it gives more weight to the largest airplanes, it triples the size D1s. Well, then we will have to go first to some tables at the beginning of the norm where we have the different configurations. For example, this is the same runway, we can see here, wait, I have done it wrong. Here we have the same runway. Obviously, if it is only a runway, the landings and takeoffs are done in the same runway. We will have to go for capacity to the chart 2 to 3 for visual and 2 to 43 for instrumental, and for delays 2 to 70 and 2 to 85. When there are two parallel runways there are more options. In this case we have the landings in one and the takeoffs in the other, and, besides, here we have the separation between the runways. Then here we have a table with different options, landings and takings off using one. In this, no, they are closer than a certain amount, they are crossed, and then, depending on these parameter, we will have to choose the chart. Well, we already know that we have to use chart 2 to 3, so we go here, that I'm going to try do it bigger, and here we see that, as there is 0% of touch and go, the factor is 1. In the case of small mixers, when there are more touch and go, this factor multiplies the capacity. Look that for mixers up to 10. If the percentage of touch and go goes from 41 to 50, capacity is multiplied by 1, 4. For bigger mixers it only affects in small percentages. Well, we assume that, if the mix of airplanes is very big, there will be fewer touch and go. But even if there are, it does not improve so much. When we only have small airplanes, the one vacates the runway much faster. Afterwards we go to see the number of exit taxiways. We have said that we have 3,100, we have seen that our mix is 45, with which we'll have to go here, from 21 to 50 in the exit taxiways. That affects us go from 3,000 to 5,500 feet. Why? Because the bigger the mix, bigger the airplanes, so the exits will be further away from the threshold. That is, if the mix is between 61 and 120, the exit taxiways will be from 5,000 to 7,000 feet. Well, we have airplanes with a mix of 41, and we have to consider all the exits that affect us, no only the fast exit taxiways, all the exits. But if have a runway for takeoffs and another for landings, we will only count the ones of the landing runway. Then here we have that, if there are 4 or more, the exit factor is 1. We go here to the right and, as I have said before, from 3,000 to 5,500 we have 1, 2, 3 and 4 exits: the 3,101, the 3,401, the 4,701 and the 5,500 feet. From 3,000 to 5,500, as we have 4 or more, 1, if we had 3 for example, it would depend on the percentage of arrivals. If it is a 40% of arrivals, a 50 or a 60%. As we have a 50, we would come here and see that it is reduced to 0.93, but is not the case. Finally we go to the chart with the mix, that is 45, to the curve of the 50% of arrivals and get a capacity of more or less 65, that we have to multiply by 1 and by 1 because this is the factor of touch and go and this is the exit factor. Then we have a total of 65 movements per hour like maximum capacity, that we have to multiply by 0.85 or 0.9 to calculate the declared capacity. And here is where it should be more or less, we are going to multiply it. 65 multiplied by 0.9 is 58. Or 65 multiplied by 0.85 is 55. What is a little bit more of what we have as a best-in-class airport capacity for a runway in visual meteorological conditions, according to the